As you know, cryptography is an important area of computer security. Cryptography is used to encrypt communications. This is its main use, but it's not the only one. Cryptography also helps to protect the integrity of information. In short, cryptography makes it possible to build many security mechanisms. Modern cryptography works on binary bit sequences, unlike classical cryptography. Classical cryptography is cryptography before the computer age. Classical cryptography manipulates characters, that is letters and digits, directly. In this course, I will not deal with classical cryptography. I will only focus on modern cryptography, that is, cryptography using computers. Cryptography allows the construction of security mechanisms to ensure different security objectives. Encryption is a security mechanism protecting the confidentiality of data. For example, data exchanged during a communication. And as we will see, there are several encryption techniques. With regard to integrity, there are several cryptographic mechanisms. The message authentication code protects the integrity of communication messages. The digital signature is a bit like the message authentication code, but its use is more about protecting the integrity of electronic documents than the integrity of data communications. And the public key certificate is for authenticating users or organizations. As you already know, the reliability of a security mechanism should not depend on the secrecy of its design or implementation. In the crypto world, this property is declined in the form of the Kerckhoffs' principle. This principle states that the security of a cryptographic system must only rely on the secrecy of the key. Everything else is public, including the algorithm. There are basically two types of cryptography. Symmetric cryptography. This type of cryptography uses one secret key shared by the communicating parties. And asymmetric cryptography. This type of cryptography uses one pair of keys, one being public, the other private. Symmetric cryptography is fast and is used to protect the confidentiality and integrity of data communications. However, the major problem of symmetric cryptography is how to share the secret key between the communicating parties. And the answer lies in asymmetric cryptography. Asymmetric cryptography is slow and therefore cannot be used to protect communications. But it can be used to share the secret key, protecting the communication between two parties using symmetric key cryptography. So this course on cryptography will be divided into two. The first module will be about symmetric cryptography and the second module about asymmetric cryptography. Cryptographers are very often mathematicians, very rigorous people. For each cryptographic system, they are used to specify precisely the model of the attacker. The objective of the attacker is to break the cryptographic system. The model of the attacker describes the attacker's knowledge and the actions the attacker can take to defeat the cryptographic system. Cryptographers then prove that the cryptographic system is secure given the model of the attacker. In this course, I will avoid these formal considerations. Not that they are not important. But this course is not a specialized course in cryptography. And I have chosen to present cryptography in an intuitive way without going into too many formal considerations.